And this is 4.7 scientific notation. I love working with scientific notation. Scientific notation is kind of used throughout the world in the scientific community. And what it is basically a shorthand way of writing very large numbers or very small numbers using powers of 10. Okay, so what we're going to be doing is taking basically just numbers that aren't that small or aren't that large today in learning how to do this. But we're going to use a power of 10, and we're going to change the number into scientific notation by doing some very simple things. Okay, now the reason we use this is because in science, sometimes you're measuring very small things or very large things, such as a very large thing would be the mass of the sun. Well, that's a very big number. And if we had to just write it all out, it would probably be a very long number. But if we use scientific notation, we can shorten it a little bit. Okay, if we're talking about the mass of an atom, very small number. But if we use scientific notation, we can eliminate a lot of the zeros that are behind the decimal, and kind of help instead of having to count zeros. The powers of 10 tells us exactly how many zeros we have in front of the number. And so we'll see that here in greater detail. A number is written in scientific notation if it has the form C times 10 to the n power. Okay, now C, this is C. Let me see if I can get a pen, see if it's going to work for me today. Okay, C, well, let's get yellow. C is a number that is greater than or equal to 1 or less than 10 and less than 10. So I kind of like to say it's in between 1 and 10. It can't be 10, but it can be 1. Okay, so this number, to be in scientific notation, this number has to be in between 1 and 10. Okay, and this is a power. This is an integer. So it can be a negative whole number or positive whole number, okay? It can even be 0. But we generally don't write powers of 10, um, 0 powers of 10. Okay, and because there's really no reason to do that. So it is, n has to be an integer, c has to be a number between 1 and 10. This is in scientific notation because this number is between 1 and 10, and this number on the power of 10 is an integer. Okay, this is a time sign, it's not an x. So this is old school time sign right here. It's always a time sign. This always goes in scientific notation. This power of 10 always goes. The only thing that changes is the number here and the power of 10. This is always the same. Okay? So write the number in scientific notation. So I'm going to take this number, 4,100, and I'm going to make it a number between 1 and 10 by moving the decimal. Well, currently the decimal is here. Where does the decimal need to be so that this number is between 1 and 10? Well, it needs to be between the first and second number, right? Okay, so I'm going to rewrite it as 4.1. And I'm going to put my big time sign, I'm going to put the big 10 there. Now all I need is the exponent. Well, the exponent comes from the number of places the decimal moves. So I moved it 3 places to the left. This is going to be to the power of 3. Okay, now remember, if I multiply this out, I should get the number I started with. A 10 to the third is 1,000. 1,000 times 4.1 is 4,100. So this certainly works. And what helps to know is when we move the decimal to the left, we get a positive number here. But when we move it to the right, we get a negative. Okay, so we did move it to the left. We made a big number small here. So this number has to be multiplied by a big number to get what we originally started with. Okay, now here, the decimal's here, it needs to be here. So I'm going to rewrite that as 3.9 times 10. How many places do we move it? 1, 2, 3, 4, 5, 6. But we moved it to the right, so it's a negative 6. Okay, the reason why is if we start out with 3.9, which is a number much bigger than this, we have to multiply it by a very small number to get our original number. Okay, so it has to be a very small number, 10 to the negative 6. Here, the decimal has to be there. So that's 3.906704. And I have to keep going till all I have is zeros at the end. I have to put in all the non-zero numbers in scientific notation. But that is a number between 1 and 10 times 10. And that's, let's see, 1, 2, 3, 4, 5, 6, 7 places. We made a big number small, so we have to make this big so that we can get our original answer when we multiply. Here, the decimal has to move 2 places to make this a number between 1 and 10. 3.0479 times 10. Now we made a small number big, so we have to make this really small. That has to be -2. Moving to the right is -2. Okay, here I just need to move it one place to make that a number between 1 and 10. 3.2502 times 10. We made a small number big, so we need to make this small to keep it balanced, to make this equal. Okay? So here, the decimal needs to be here. It's already here. 1, 2, 3, 4, 5, 6. It's going to be 5.020575, and I have to put all these non-zero numbers in. Now, if I just had zeros out here behind this last 5, I don't have to include them. But if I've got a non-zero number out here, I have to include those and the zeros in between. Times 10 to the 6th power. We made a big number small by moving the decimal here, so we have to make this big so that when I multiply this times this, I get my original number. Okay, next page. Write the number in standard form. Well, this is very easy. Let's start out with the number we're given. This tells me how many places to move the decimal. And if I multiply this by 10 to the 4th, it's going to be a bigger number, so I need to move it to the right. 1, 2, 3, 4. And in my little dips, I need to put zeros for placeholders. 71,000 is my answer. 1.93 times 10 to the -3. Now this makes it a very small number, so I have to move it 3 places to the left. 1, 2, 3. There's a 0 and there's a 0. Okay, 0.00193. Now this is 3.641. -6 tells me how many places to move it. It tells me to make it small. 1, 2, 3, 4, 5, 6. Decimals there. I've got 0, 0, 0, 0, 0. Now I don't have 6 zeros. I move it 6 places. I had to have 5 zeros to fill in here. 5.59 times 10 to the 8th. Well, 1, 2, 3, 4, 5, 6, 7, 8. There's the decimal. I'm going to have 1, 2, 3, 4, 5, 6 zeros because I already had 2 non-zero numbers there. Okay, 1.06 times 10 to the 2nd. Well, 1, 2. Remember, this makes it bigger. Positive integer, positive power makes it bigger. Negative power makes it smaller. So I've got to make this bigger, move it to the right. 106 is my answer. This one, this makes it smaller. I've got to move it to the left. Okay, move it 1 to the left. 0.9905 is my answer. Moving on. Greater than, less than, or equal to. Well, let's keep these. Let's put these in scientific notation so we can compare. Okay, this is 7.1 times 10. This is 1, 2, 3, 4. 10 to the 4th. Well, this is 10 to the 3rd, and this is 10 to the 4th. The bigger power always wins. Bigger power wins, so it's the biggest. That's bigger. Okay, let's put this in scientific notation. So I'm going to move the decimal here to make it a number between 1 and 10. 1.24 times 10. Now move it 1, 2, 3. Now I'm moving it to the right. I'm making a small number big, so I need to make this small. So it's -3. Well, again, the biggest power is the biggest. -3 is bigger than -4. It doesn't matter what the first numbers are, the power always wins. Okay, now here, again, this is 8.4 and this is 1.2. Certainly this is bigger. But 10 to the 4th is smaller than 10 to the 5th. 10 to the 4th is 10,000. 10 to the 5th is 100,000. 100,000 times this is more than 10,000 times that. Bigger power wins, always. Okay, so they were all basically less than. These were all less than. Okay, find the product. This will be the last thing we do. To do this, we have to multiply the like parts. Okay, so I need to multiply 25 times 15, or 2.5 times 1.5, and that gives me 3.75. Okay, so 3.75. I'm going to have the times sign. I'm going to have the 10. I don't multiply 10 times 10. When I multiply things with exponents, I add the exponents, but I keep the base the same. So it's 3 plus 2, which is 5. And this is done. 3.75 times 10 to the 5th. Let's multiply the like parts here. Okay, I've got an 8.5 times 9. Okay, and that gives me 76.5. Put the times sign, put the 10 there. -5 plus -2 is -7. Again, I'm multiplying two things that have the same base. I just add the exponents together. Okay, the problem is this is not a number, notice, between 1 and 10. I have to fix it. I fix it by moving this decimal one place. And if I move this decimal one place to the left, I have to bump that up one. So it's 7.65 times 10 to the negative 6. Remember, negative 6 is one bigger than negative 7. Okay, here, 7 times 6, like part to like part, that's 42, times 10. Well, 10 to the 4th times 10 to the 5th is 4 plus 5, that's 9, 10 to the 9th. Again, this is not a number between 1 and 10. I have to move the decimal to make it that way. 4.2 times 10. Now, this is up 1. Because I moved the decimal to the left, I have to move that up 1. That's 10 to the 10th. Okay, and that's pretty basic, pretty straightforward. That's how you find powers. Ordering from least to greatest. I think if you put them all in scientific notation, it will be very easy. Let's do this one in scientific notation. 3.5, move this over 1, times 10. Now we're making a small number big, so we have to make up for that by making this small. Okay, 10 to the negative 1. Biggest power is the biggest. These two have the biggest power, so this one's definitely the smallest. Now when they have the same power, you compare the first numbers. Okay, 3.5 is bigger than 1.5, so this is the second, and this one's third. Okay, let's look at the next one. Let's make this scientific notation. That's 7.304 times 10 to the 1, 2, 3, 4. It's positive 4. Okay, positive 4 made a big number small, so we have to make up by making this big. Okay, well 10 to the 5th is the biggest because 10 to the 4, 10 to the 4, 10 to the 5th. Okay, 10 to the 5th is the biggest. Now just compare these two. Which one's the smallest out of these two? They have the same power, so look at this. The first number, that's the first one, that's the second one. Okay, one more of these. Let's change this. 7.6 times 10. That's going to be 1, 2, 3, 4. It's going to be a negative 4. I'm moving it to the right, negative 4. Now compare the exponents. Well, negative 5 is smaller than negative 4, so that's the smallest. Okay, these have the same exponents, so compare the first numbers, 7.6 and 8. Well, this is the next one, and this is third. Okay, that's ordering from least to greatest, and that concludes our lesson for today.